Hello and welcome to a video on graphing rational functions. Now we're going to graph a couple rational functions that pretty much have everything that rational functions can have. They're going to have holes, vertical asymptotes, either horizontal or oblique asymptotes, intercepts, and so on. And we're going to use all these clues to help us to form the graph. So first we look at the equation, and from the equation we're going to pull out all the pieces that we can get, like holes as ordered pairs. So we're going to get the x and y coordinate, x-intercepts, y-intercepts, vertical asymptotes, and behavior. And then we're going to plot all these things, put them together, and see if we can figure out what the graph is. So we'll kind of leave the area of the graph for just the graphing. Okay, so let's look first at factoring the polynomials in the numerator and polynomial in the denominator. So let's see what we get. So we have f of x is equal to, and I can factor an x out of the numerator, and I get x squared plus 3x plus 2. And in the denominator, it looks like I can factor out a 4. So I have 4 times x squared plus 6x plus 8. Okay, we can factor both of those a little bit further. So for the numerator, I still have the x, but I can break it down into two factors, x plus 2x plus 1. And in the denominator, I have the 4. And I can break this down into two factors. I'm looking at the x squared plus 6x plus 8, so how about x plus 4x plus 2? I'll put the 2 first just so we can see the factors. Okay, so we can see there's a common factor here, so we're going to take that out, and that's going to be our whole. So the way that we're going to look at the function now is that f of x is going to be equal to the reduced rational function, which is x times x plus 1 over 4 times x plus 4 with a whole at, and what makes the canceled term 0, the 0 of x plus 2 would be negative 2, so that's going to be the x coordinate. And the y coordinate, we're going to have to plug in a negative 2 and find f of negative 2. So let's find I shouldn't have closed that parenthesis. It's going to be an ordered pair, so let's leave that negative 2 alone for a minute. And we're going to find the y-coordinate by finding f of negative 2. So f of negative 2 would be negative 2 times negative 2 plus 1 over 4 times negative 2 plus 4. That's negative 2 times negative 1 is 2. And negative 2 times negative 1 is 2 over, let's just write this, 2 over 4 times 2, which is 8, so this is 1/4. So there's our whole. Okay, now let's look at our reduced function. So I'm going to work over here and just do the basic stuff with x times x plus 1 over 4 times x plus 4. So our reduced function now, f of x is equal to, I need to look at that one more time, x times x plus 1 over 4 times x plus 4. So from this we can get the x-intercept at x equals 0. So our x-intercepts will be at x equals 0 and x plus 1 equals 0. So x equals negative 1. There's our x-intercepts. Our vertical asymptotes, or 1, will be at x equals negative 4. Don't forget, this x equals negative 4 is an equation, while these two are just points, they're just numbers. And our y-intercept will be f of 0, which is 0. Well, actually I can look over here. The easiest place to find it is right over here. I have 0 over 32, which is 0. Okay, so I've got a y-intercept of 0. All right, one more thing that we need to do before we can plot this and before we start putting all this information onto the graph is to get the end behavior. So when we look at the function and we see that the numerator is third degree and the denominator second degree, that tells us that we need to do long division to get the oblique asymptote in this case. So we need to do the whole thing with long division. So let's see, we have 4x squared plus 24x plus 32, into x to the third plus 3x squared plus 2x. All right, so the first question here is the trickiest one. What do we multiply 4x squared by to get 1x to the third? And what I suggest when you run into something like that, we're looking at what do we multiply this by to get this. It almost seems like there isn't anything, but it's a higher degree, so there is. So we're going to do it like this. We're going to do 4x squared times what? Well, let's call it a is equal to x to the third. And so we divide both sides by 4x squared, and so we get a equals x to the third. Just write it out. X to the third over 4x squared, or cancel two of those x's, we get x over 4, or 1/4 x. There we go. We did find something. Oops, there's something there, 1/4 x. So that's what goes up here. Now once you find it, it's not too bad because we can multiply that 1/4 x. We multiply by 4x squared, we get x to the third. Multiply that by 24x, we get 6x squared. Multiply it by 32, we get 8x. And then we're going to subtract this whole mess from the other one, and we get x to the third minus x to the third, which is 0. We get 3 minus 6, which is negative 3x squared. We get 2 minus 8, which is minus 6x. And now we can do this one more time, and I'm going to suggest the same method. And we want to know, what do we multiply 4x squared by to get negative 3x squared, and is that possible? Well, let's see. So if we do 4x squared a times or equals negative 3x squared, let's see if something works out that. So 4x squared times a equals negative 3x squared. Divide both sides by 4x squared, and we get a equals negative 3x squared over 4x squared. It's actually just negative 3/4. So there we go. So we've got 1/4 x minus 3/4. And anything else will be a remainder. We can multiply this negative 3/4 out, and we get negative 3x to the negative 3x squared. 3/4 of 24. The 4 cancels, we get negative 18, so that's minus 18x. And then 3/4 of 32 would be negative 24. And that doesn't all matter because we're just going to subtract and we're going to get a remainder. And remember, the remainder goes to 0. We don't need to worry about the remainder. We've actually already found our oblique asymptote. But if we subtract here, we get 0, and we get negative 6 minus negative 18, that's 12x, and then subtract 0, there's like a 0 here, minus 24 is plus 24. So that's the remainder, and so the oblique asymptote is y equals 1/4 x minus 3/4. Okay, now we're ready to put all this information into the graph, and let's see what we get. Okay, this is the fun part. So we've got, let's look at our numbers, and I'm just kind of looking around. I see a negative 4 for a vertical asymptote. I see a negative 2. I'm looking for the biggest numbers so I can figure out how big to make my scale. And it looks like I just make it like 5 should do it because I've got negative 4 is the biggest. So I'm going to go, let's go to 6. So 1, 2, 3, 4, 5, 6. And then same in the negatives. 1, 2, 3, 4, 5, 6. I'm going slow enough that I can try to make them evenly spaced so that it's an actual, somewhat accurate graph. All right, let's put in the vertical asymptote, and I'm looking for it, and that's at negative 4. So my vertical asymptote is here, and my oblique asymptote has a y-intercept of negative 3/4, so right about there, and then a slope that goes up 1 and over 4. So it's going to go up 1 and over 1. 1, 2, 3, 4, so it's right there. So there is my, let's see if I can make this kind of straight. There's my oblique asymptote. Not bad. Just going to make one more line, even though it might overlap with the numbers a little bit. Okay, so I've got my 2 asymptotes. Now what's important is I've got one vertical asymptote. and there's going to be one branch of the curve, or one interval that has a smooth curve to the left of that vertical asymptote, and then there's going to be another interval with a smooth curve to the right of it. And we'll get a lot of idea once we plot our hole and the other intercepts here. So we have -2, 1/4. So there's a hole something like right there. And then there's an x-intercept at 0 and -1. So right about here and here. And then there's a y-intercept at 0, and I think I've got everything. And I think I can get a pretty good idea of what the curve looks like now, because I know that there's another x-intercept. So I'm pretty sure this has got to go up here. It can't possibly go down, or there'd be another x-intercept. It has to go up. This one, there's going to have to be a local min between these two x-intercepts. So it's going to go through here, local min, and come back up. There's no other possibility. Now it's going to go towards the asymptote. So at some point you got to make sure you bend it towards the asymptote. All right, that's that branch. That pretty much covers the branch to the right side of the vertical asymptote. Now we need to think a little bit about what's happening to the left side of the vertical asymptote. And think about it. There's no way that this curve can hug these asymptotes without, if it's up here, if it's anywhere up in this area, it'd have to cross the x-axis. So it's got to be down here. So we know our other branch is down here. I don't require you to get any more points. I just want you to know where that other branch is. And there you've got a pretty good idea of the curve. Not so bad of an idea to label our hole, even though it's there. -2, 1/4. To label our x-intercepts, this is supposed to be an intercept at -1, and then there's one at 0, and that's about it. Okay? Ready for example 2? Okay, so I'm going to do example 2 in a different video. So I hope you found this helpful, and part 2 is coming up.